So, without further ado, let's get started. I'm very happy to turn it to Frank Reuter, our Cavipor expert and speaker of today's webinar. Frank played a key role in inventing Cavipor and is driving forward the development since more than a decade. Frank, the stage is yours.
Yeah, thanks, Kim. And thank you, everyone, for joining today's webinar. It will be my pleasure to give you a deeper insight into Cavipor, the clay foam technology that we all have. And yeah, but before going into details in the technology, perhaps a few words to myself. So my name, is Frank Reuter. I'm a chemist by training. I did my chemistry studies and also the PhD in the universities of Mainz and Dijon, the doctorate in inorganic chemistry. And from 2011 on, my journey at BASF started. I started as a lab manager at the research center here in BASF SE in Ludwigshafen. So perhaps you're familiar with the Ludwigshafen site. So here's a little picture of the very big site. So it's in length 5 kilometers and in width 2 kilometers. So it's the biggest Verbund chemistry site in the world. So it was my pleasure starting here in 2011, as I said, as a lab manager. And from 2015, I got involved with the development of Kavipore. That day, 2015, it was really just an idea or a small project. And after 11 years now, we brought it with the team from the lab scale now really to the market. And of course, that was not me. I said it was the team represented here by Gerion Sommer on my right side on this picture, taking care about the technical management. And on the left side, it's Angela Stangl taking care about the commercial management. But of course, there's a lot more hats behind one product. So I thank at this stage here everyone involved in the development from R&D side, so in the lab, in the production, in the communication. So Kim Lindner and the team, the logistics, supply chain, the customer service, and so on and so forth. So thanks to all of them here at the beginning of the speech. And now I will give you the insight into the Kavipor technology. And what I would like to take home and what I will show you is that Kavipor is an in-situ insulation system made out of 3 harmless components and air. It is mineral-based, that's why we call it clay foam. It is thus non-combustible and fully recyclable. It's approved and sold in Europe and the UK for the use in cavity wall insulation, but due to its properties, which I'm going to present you in a minute, it is also approved for a lot of further application. And that's why we claim it, a bit derived from the BASF claim, as the reliable insulation system for a sustainable future. So now really, what is it? It's the world's first 3-component system for the production of an in-situ clay foam, meaning that we have 3 components, and this is what we as BASF do. This is what we as BASF invented. It's the 3 components which you see here. So on the first one is the template component, comprising a surfactant package and some additives. The second component is the filler, containing binder, so some organics is there, and mineral particles. And the third component is the crosslinker, containing a crosslinker species, which we need for crosslinking the whole system. All these 3 components are water-based. So you see, we can fill it into IBC containers and deliver it to our customers in this liquid state. Our BASF contribution was, as I said, the development, and nowadays we produce it, the 3 components, and of course we deliver also the technical support to our customers who are interested. Everything is patented by BASF, so the formulation, meaning the recipe, the process, and also the application of this mineral-based system. Now, I'm going to explain you how the foam is made out of these 3 components. It's described here in 3 steps. So first step is the mixing of the template component with pressurized air. So as you know it from your home, when you take a soap and mix it with air, you will get a bubble. And a lot of bubbles create the foam. So this is the principle behind. So we take the template component, mix it with pressurized air, put it through the foaming chamber, and we will get the soap foam in step one. Step two is then the addition of the filler. As I said, the filler contains the binder and also the mineral particles. And by the aid of a static mixer, this filler component is mixed onto the lamella of the foam. So equally distribution of the filler, meaning the binder and the minerals onto the lamella. Third step is the addition of the cross-linker, which then leads in a chemical reaction to the cross-linking process. So that we call it gelation process, where the cross-linker from the third component and the binder from the second component react to result in a jelly-like structure. But this process takes some time. So we're talking about 1 to 2 minutes when the foam is flowable. And of course, this is very, very important because we want to pump or to bring the foam in a liquid state before this gelation takes place into cavities, voids, whatever you think. And then when we brought the foam into this cavity, everything is at place. So it sets, it dries, and then it performs. Of course, we must take care that the three components are mixed together in the right ratio. So depicted here, we need 1 part of the template, 4 parts of the filler, and 0.6 parts of the cross-linker component. In the next video, you will see how the process is done just in the lab. So we screened round about 6,000 formulations by that kind, as you see it here, to end up with now the final formulation that we produce and that we sell to our customers. So as I described, the creation of the soap foam is pretty simple. In the lab, we do it with a kitchen mixer. So the soap solution and the kitchen mixer and the air results then in a nice soap foam before the second component is added. And in that case, also with a kitchen mixer, homogenized, nicely distributed here, the mineral particles and the binder. You see the grayish color, so everything is now nicely homogenized. Addition of the third component, now the cross-linking process takes place, but not instantaneously, as you see, as the foam is still flowable. But now when we go with a spatula through the foam, you see it gets stiffer. It does now in that state not flow back, but you can tear it apart. And that's the more or less gelated state in which the foam will stay stable in the cavity or wherever you brought it into. Of course, on the construction side, you cannot deal with a kitchen mixer or perhaps a mortar mixer, but that's why we also, in parallel, invented the dedicated machinery. So as you have seen, all the three components must be mixed in the right ratio, and that's why we have an automated machine really controlling the flow of the three components. And if something is going wrong, it will adjust automatically. Or if, for example, one of the components run dry, then the machine will stop. So of course, and that secures our workforce that when there is a foam created, it is mixed in the right ratio and the right components. You see here, our customers just have to deal with the unit pressing one button. So the green button is for start. And yeah, there the nice creamy foam is created. You see it is flowable, so it can easily brought into any kinds of cavities. And by pressing the stop button, the system will stop. There are some blows to blow out the the residual material that's in the mixing unit, and then everything's clean. So, and now what to do with this foam? You can see it here on the picture. For example, you can bring it into cavity walls. That's also the purpose and the application that we invented Kavipore for. So for those of you not familiar with this kind of construction, which you find mostly in the northern part of Europe, but as we learned also in the south. So we have now our first customer and application in Italy, for example, but the principle is the same everywhere in the world. So we have an outer layer, an inner layer, and there in between of this wall, there is a cavity, which is usually somewhere between 4 and 15 centimeters in width. And this cavity in the older houses is not filled with anything but air, but the air has a problem because it convects in this space, meaning we have the exchange of temperature, of heat within the cavity, but also as most houses have a certain age, there are some cracks and some voids in the outer wall. So we also have the exchange of temperature between the air in the cavity and the outside world. And this is, of course, insulation-wise and energy efficient-wise, a disaster. And that's why people started to bring insulation material inside of this cavity wall. Yeah, there is already available different materials on the market, but at least to our eyes, there is a lot of drawbacks that come with these materials, and that's why again we started the invention of Kavipore, as it will just bring the benefits that you need for insulation of this cavity wall. Principle behind is pretty easy. So in the next picture, you will see how it is applied into or injected into this cavity space. Here you see a wall with 3 holes drilled into the joints of this outer wall, and the diameter of these drilling holes is about 20 to 16 millimeters, so that they are really small enough not to scratch the nice bricks. The principle of filling is pretty easy. For example, in that case, on the bottom right hole, you will put into the nozzle and start the filling. And then time by time, the foam is pumped into this cavity. And when it reached the hole at the bottom left, for example, there is something like a little stick put into this hole. And when the stick starts to move, the applicators know that all the distance between the right and the left hole is filled with Kavipore or with this clay foam. And then they stop the injection on the right, move the nozzle to the left hole and start again. And so meter by meter, our applicators fill the whole house, the cavity of the whole house with the clay foam material. But we also have another big benefit in application because we have no dust flying around. We have no fibers flying around by applying this material, meaning that you can also observe the filling of Kavipore into this cavity with some optic devices, for example, like a borescope, which is not the case when you use some fibrous or particular material, because then you just see the dust flying around. And after everything is applied, you see a nice homogeneous, seamless insulation layer like on this picture here. So here we have a 1.5 meter times 1.5 meter acrylic glass wall, just to see how it looks like when everything is filled completely. In real life, here's 2 pictures from a construction site from our customer in the Netherlands. So on the left side, you see the little trailer with which our customers arrive at the construction site. On this trailer in the back, you see the machine. This is the 3rd generation of the machine. Now we're with the 4th generation of the machine. So still there is some development ongoing, but it works fantastically. Yeah, you see also, besides the machine, the 3 IBC containers. To be honest, you see just 2. The 3rd one is behind the little IBC containers. So in the big one, there is the filler component, and in the smaller ones is the template and the cross-linker. There is also the air compressor, because we need some pressurized air to form the foam. And all the four components, so the three liquid components and the air, are then pumped or brought through this hose package, which you see at the front of the trailer, to the back side of the house in that case. So now we come to the right picture. And on the right side of the right picture, you see this mixing unit of the machine. The three components, the three liquid components and the air are brought into this mixing device, and the whole process that I have described of the foam formation takes place within some seconds, 2-3 seconds. And the final foam, so the ready mixed foam, leaves the mixing unit in this a bit bigger grayer hose and then is brought through the nozzle into the cavity. And on the right picture, you see the installation. So the guy on the knees is now applying the Cavipore into the walls. In the bucket, there is some mortar to fill up the drilling holes after application. And if you look closely behind the shoulder of this guy, this little orange device, this is the optics. So this is a borescope with which everything can be monitored. But besides the cavity wall insulation, clay foam properties also offer more application scenarios. For example, to fill it into exterior or interior dry walls. So the timber or metal frame walls, which are usually cladded with gypsum boards. Or you can bring it into roof or floor slabs. So from the outside or from the inside by drilling holes. So for the roof and floor slab application on the left side, this was our first house that we have filled in Turkey some years ago. Pretty successful. It was the first trial. It was in Corona times, so pretty remotely, but pretty successful. And on the right side, you see a mock-up for a pitched roof that we filled in our laboratory in presence of the Fachverband der DachdeckerInnung. So it was the Roofer Association in Germany present to supervise or develop together with us the best application of the foam in a renovation state of a pitched roof. And on the upper right side, there is two pictures from another application that is possible, namely the filling of hollow building blocks with Cavipore to increase their insulation properties. So now, what are the properties of the material? Here you see depicted the composition of the fresh foam that now has left the nozzle. You see in the back the morphology of this foam. So we have a closed cell foam, as you know it from soap bubbles, of course. We have a density of 110 grams per liter. And as I said, it's closed cell. And here on the outer sphere, you see the composition. So we're talking about 30% of the material is the solids, so namely the organics and the mineral particles. And 70% of the foam is water. We know that's quite a lot, and that's why we also are working on reducing this water part down to 40%. We're working on that, but still, even with a 70%, we get very nice results there. So now the foam is applied, for example, into this cavity wall, and the foam starts now to dry out. And the drying process is a bit special because it releases no liquid water, the foam. The water is just evaporated as fast as the environment allows it. So meaning that we need some diffusion open layers. For example, these bricks, they are open for diffusion, also sandstone, also the gypsum boards, for example, that's all fine. And as fast as the material allows it, the foam will dry. And we're talking about really a period of 2 to 4 months in the case of cavity wall insulation. When the system has dried, of course, all the solids are left, and this is what we call the dry foam, with a, of course, reduced density of 30 grams per liter and an open cell structure, as you might see in the back. So the picture and the morphology has changed. Now we have an open port system. And this dry foam consists of mainly the mineral particles, so mineral type 1 and mineral type 2, which is mainly the clay material, and this is again why we call it clay foam. And 10% organics, which is mainly the binder system, but also the surfactant package is still present in the dry foam. So we now have an open cell structure, but, and that's perhaps some kind of miracle of chemistry, even though we have these open pores and even though the whole system is based on water or on aqueous components, the final foam will not take up any liquid water. So it's hydrophobic, as we call it, and thus is a water barrier. So that brings us to the property setup of the clay foam. So of course we invented the material because we want to have a thermal insulation, and the lambda value of the dried foam is about 32.8 milliwatts per Kelvin meter measured in the lab. Of course, we get some adders to get to the declared lambda value, and this is 35 milliwatts per Kelvin meter, which is comparable to the lambda values of urea formaldehyde system or EPS or mineral wool, which are the material that you also find out there in the market for the application in cavity wall insulation. But compared or in contrast to these materials, we have focused on the development of a safe system. And this safety, you will on the one hand side see that we have the best IMI code emission class. So there is, in quotes, no, to be more scientific, very low VOC emissions, but still the emission class EC1 plus is the best that we can get for construction material. We have no fibers flying around. We have harmless components, meaning that the application of the material is very, very nice for our customers. And the third point, of course, is also very, very important. Now, looking back into a few days to the Hong Kong scenario. So if you have seen it, so the burning skyscrapers there, non-combustibility gets more and more important nowadays. And there we have the classification as non-combustible material, which is tested, of course. We have the A2 classification, A2 as 1D0. And also just to give you some visual impression how the material behaves when a flame is applied. I would start the next video. And what you see here is the so-called mini SBI test. SBI is for single burning item. So this is one test that you have to pass to get the classification non-combustible material. And what you see here is on the right side and in the background, there is a dried panel of Kavipore and a flame with a defined heat source is applied onto the surface of these panels. But as you see, it's pretty boring to watch. It's perhaps a bit relaxing this Christmas time, but there is a smut formation on the surface from the flame, yes, but nothing else. So the material is not burning. There is no smoke release. There is no dripping off. And that's why after 20 minutes, that's the timer that you see also here, after 20 minutes, which is the test period, nothing has changed. So we also measured the heat release, and this is very low, This is why we end up with a classification as non-combustible. Okay. Next little video that you see here is just what happens in a small burner test. So applied again a flame or a heat source, which is a bit more in temperature or a bit higher in temperature onto the panel. But yeah, as you have seen also here, there is a bit of smut, but nothing else. So no burning away, no dripping, no smoke formation. To complete the property list, coming to a very, very important point these days, it's the sustainability. Therefore, we have driven an EPD, an environmental product declaration, which you need today for all the construction materials that are certified. And here we have driven the EPD, revealing as one of the points that are looked into in the EPD, the very low CO2 footprint, which is about 0.5 kilograms CO2 equivalents per kilogram material. And this is much less than for the fossil-based insulation materials like urea formaldehyde, the EPS, or polyurethane, for example. And another major point of sustainability is the recyclability. And here, with the clay foam system, we have a system that in the case of tearing down a house, or for example, doing some modifications, adding a window or adding a door or whatever, you can leave the clay foam system with the construction waste, with the mixed construction waste, as it can be recycled or even reused. For example, as foundation material for streets or parking lots, or if you have Kavipore in the pure state, we as BASF, you can send it back to us and we can reuse it really as a replacement of the filler component, so of the mineral particles in the filler. And some further nice properties of the system is due to its open porous structure, it has very nice sound absorbing properties. It is water repelling, as I said, but in contrast to the water repellency, the vapor can diffuse through, meaning that the system per se is breathable. It can adapt to the moisture content of the air, it can adapt to the relative humidity inside, outside, and also contribute to a very nice living atmosphere in the house. So this is just a small list of properties of the clay foam. You'll find more information, and since 3 weeks now, you will also find more informational video clips in our Kavipore Academy on www.kavipore.com, which I invite you to. Yeah, now coming to the question, pretty nice product. How can I get it? So you will not get it if you're interested as a house owner, for example, from us, from BASF. And that's because we have a pretty nice clay foam network, as we call it. So you see here on the list, we're not just located in Germany. We have also some suppliers in the Netherlands, in UK, and also in Ireland. And as I already said, since a few months, also in Italy. And of course, we're looking for new partners of this network. As you see on this map, there is some spots to fill where Kavipore can be applied. But our suppliers, they offer the clay foam system under their own brand. So please, if you are interested, if you have houses or some objects to fill, please contact our partners that you can see listed here or on www.clay-foam.com. There you will find the clay foam suppliers, but also the machine providers where you can get a machine from. So I'm at the end of my little talk, of my little introduction. And as I said, I hope you take home some key facts. For example, that Kavipore is an in-situ insulation system made out of 3 harmless components and air. It is mineral-based, mainly by clay particles. That's why we call it clay foam. Thus, it's non-combustible and fully recyclable. It is approved, sold, and applied in Europe, UK for cavity wall insulation. And it's also approved for a lot of further application, like the floor slab, the roof, the stones, and the drywalls. And this is why we say that Kavipore is the reliable insulation system for a sustainable future. And with that, I come to the question and answers part. Thanks a lot, and happy to answer your questions.
Thank you so much for the nice introduction, Frank. And as you said, now we have some time for a question and answer session. So please feel free to send any questions you have about Kavipore to Frank with the Q&A tool. So you can just type in your question there. And yeah, let's start right away with the first questions we received during the webinar. So there is one question regarding if there are any restrictions on the climatic zones in which Kavipore can be used. So is it also possible to use Kavipore or clay foam insulation in hot and humid climates?
Yes, so of course, the heat insulation protects against heat and cold. So the application there in general is doable, is thinkable. Concerning the high humidity, that will of course have an effect on the drying time of the Cavipor foam, the fresh foam, but still the drying time will be longer. But I'm pretty confident that that the material will dry. Perhaps we can derive some calculations with the WUFI tool. So that's an expert tool where you can figure out using the external conditions, how long it will take that a material can dry out, or how it behaves in certain circumstances with different temperatures and different relative humidities.
Okay, thanks. The next question is, what is the minimum thickness of the cavity layer required for clay foam insulation?
So we have in our certification a minimum of 4 centimeter width of the cavity. These 4 centimeters is the minimum just due to the fire test, because in this fire test we must handle dry panels of Kavipore, and we couldn't handle panels that are thinner than this 4 centimeters. So in theory, or for applications, or if you have on a wall or house, any regions where you have less than 4 centimeter space, technical wise, that's no problem also to fill.
Okay. And a question we always receive a lot, and it's of course interesting, is how much does clay foam insulation actually cost compared to other solutions?
Yeah, that's of course when talking about interested parties, yeah, always a question. And here my standard answer is, first of all, we don't give any prices, because our customers are the ones giving the prices to the house owners, for example. But we can say that it's not the cheapest raw material, but all the benefits that Kavipore or the clay foam system brings in comparison to the fibrous mineral walls, for example, or to the EPS beads that might fly out over time from the cavity, that comparing all the costs, we are cost competitive to these ones, bringing in more value, of course.
Okay, I think you already touched a little bit on it, but the next question is also related to the benefits of clay foam compared to conventional solutions for blow-in insulation. Can you maybe elaborate a bit more on the benefits of Kavipore compared?
Yeah, I mean, we developed it for the application in cavity wall insulation, so it brings all the benefits that you need for the cavity wall insulation. And for this application, I see the biggest benefit is the water repellency, meaning that no water can enter the cavity or the inner wall through the insulation material, which is not the case, for example, for the other insulation materials like EPS beads or the fibrous materials like mineral wool, so glass wool or rock wool. And yeah, working with this material, so with the mineral wool also is sometimes a pain. So in literally, because we spoke to some appliers that that work every day with the mineral wool, and they want to get rid of mineral wool because it's really, as I said, a pain in the summertime when you have an overall, the protection overall, the goggles and everything. But still, these little fibers fly around, itching and scratching at the end of the day. And yeah, everyone who has worked with this material knows that it's yeah an awful material to work with, and that's not the case with our liquid applicable foam.
Okay, thanks for
And of course,
explaining that.
yeah, of course, another benefit compared to the fossil base, so the polyurethane or the EPS, is the non-combustibility.
Mhm. Okay, another question from the audience is it also possible to apply Cavipor or clay foam by myself, for example, when renovating a camper van?
Interesting application, but no. So for now, the material is still available through our customers or the trained installers. So as you have seen, there is a machine that the people work with, and they I mean, I explained it's simple and it's easy, but still you have to have the knowledge how to use all that system, and therefore, for now, you need a special training, and the material is also not available in a DIY store, for example, in little cartouches. So you have to call someone in your vicinity who knows how to work with it.
Okay. Someone is asking again, what exactly does clay foam consist of? So what is in this foam next to the clay minerals?
Yeah. So as I said, 90% is mineral particles, of which the main part is clay particles. There is also some gypsum in it, and there is also some graphite in it in a minor portion. And that's why the grayish color appears. So this is due to a minor portion of graphite that we need to decrease the lambda value, so the thermal properties. And 10%, as I said, is still organics, which is the binder system. And the binder system is mostly a polymer, and this polymer is approved to be in food contact. So this is also used in the paper industry, for example.
Okay. Another question, are there any restrictions for using Cavipor in attic floors?
The main restriction, I would say, is that there is, of course, the vapor openness. So the layer, the down layer or the upper layer must be open for diffusion. And that's the main restriction we have. As I said, we already now are working on reducing the water content. And there is two reasons behind. First one is, of course, that if we apply less water, then less water has to dry out. So the drying process will shorten. On the other hand side, also we save some weight. And if you think in attic floors, for example, or the pitched roof, we have sometimes spaces which are larger than 15, sometimes 20, sometimes close to 24 or 25 centimeters. That's also some weight that weight load that we put on when we install Kavipor. And reducing that weight is can easily be done by saving some water out of the system.
Okay. From my point of view, I think all questions in the Q&A tool are answered. So I think you answered all of them, and everyone is aware. But if there are any questions coming up after the event, you're of course invited to reach out to the Kavipore team. I'm sure they will answer also after the webinar. Yeah, so I think we can actually end the webinar. Thank you very much for joining, for your interest, and also for your many questions. And as Frank said, you're invited to also have a look at our Kavipore homepage, where you can find a lot of videos about the different properties of Kavipore and a lot of other information. So thank you very much. The recording will be available to you also afterwards. So if you know anyone who might be interested in Kavipore as well, feel free to just share the link with them. Thanks very much, everyone. Have a nice rest of your day.
Thanks also from my side. Take care, and happy to answer your questions afterwards. Bye-bye.
Bye-bye.